Okay, continuing problem number 23. Here we got d sub y equaling to 4 minus 30. We subtract that, you'll get negative 26. Okay, now we're going to find out what x and y is. Your x is always going to be d sub x divided by d, which means in this case your d sub x is negative 78. Your d is negative 26, so negative 78 divided by negative 26 will be 3. And then your y would be d sub y divided by d. In this case, that d sub y was the negative 26, and d was also negative 26. So negative 26 divided by negative 26 will be 1. So the solution to that would be 3 and 1. Okay, so that's how we apply Cramer's rule to solve this system of equations. All right, number 24 is finding the determinant. Here we got 3, negative 2, 1, 2, 4, 3, negative 1, 5, 1. And the way that we can solve this would be to rewrite the first two columns of this matrix here. So in this case here, I'm going to rewrite the 3, 2, negative 1. That's the first column. The second column, negative 2, 4, and 5. So here I'm going to do the product of these three diagonals going in this direction. And I'm going to add them together. Okay? So for this first diagonal here, if I do 3 times 4, that's going to be 12. 12 times 1 will be 12. And then plus the product of this diagonal here, the negative 2, 3, negative 1. Negative 2 times 3 is negative 6. Negative 6 times the negative 1 would be a plus 6. Then I'm going to add to it the product of this diagonal going in this direction here. 1 times 2 will be 2. 2 times 5 will be 10. Okay? And then next I'm going to subtract. And here's what I'm going to subtract. The product of each diagonal going in this direction, from the lower left to the upper right. So it's always going to be a minus for these diagonals here. So for this diagonal, it's going to be a minus, whatever the product of this is. Negative 1 times 4 is a negative 1 times 1 will be negative 4. So it's going to be minus a negative 4. And then minus this diagonal's product right here, 5, 3, and 3. 5 times 3 is 15. 15 times 3 will be 45. And then minus this diagonal right here, 1, 2, and negative 2. 1 times 2 is 2. 2 times the negative 2 would be negative 4. Now we can type all of this in the calculator if we want to, or just simplify it if we can, by doing this. 12 plus 6 plus 10 minus a negative 4 will be plus 4, minus 45, and then minus a negative 4 would be plus 4. So if I do 12 plus 6 plus 10 plus 4 minus 45 plus 4, that will give you negative 9. So the determinant for that matrix will be negative 9. Okay. All right, number 25. Using the change of base property, we want to find the log to the base 3 of 17. And we're going to round to the nearest hundred. That means the 2 decimal places here. Now, Using the change of base property, log to the base 3 of 17 will be this. We take the common logarithm of that number, 17. That's going to be divided by the common logarithm of our base, which is 3. And from here we can type this in our calculator. So here we press the log key, which is on the left hand side, then 17, close the parentheses. So you have log of 17, whatever that is, divided by log of 13. Log of 3. Close parentheses. So the log key is to the left of the number 7 key, and then 17, close parentheses, divided by log 3, close parentheses. Hit enter. To 2 decimal places, you'll get 2.58. So that's what log to the base 3 of 17 will be, 2.58. Alright, number 26. Here we're going to expand the logarithm in terms of log of m, log of n, and log of p. Here we got log of p to the 9th times the 4th root of n, all divided by m to the 5th. So here we have to use a combination of rules, the product rule, the quotient rule, and the power rule. Right off the top, I see a numerator and a denominator, so that tells me I have the log of the quotient. So here I have to apply the quotient rule by expanding that as the difference of their individual logarithms. So this will be the log of the numerator, which is p to the 9th times the 4th root of n, minus the log of your denominator, m to the 5th. So here I got the log of the product here. So here I need to expand that by applying the product rule, by writing it as the sum of the individual logarithms here. So log of p to the 9th times the 4th root of n would be the log of p to the 9th plus the log of, now the 4th root of n, I'm going to write that in its equivalent exponential form as n to the 1/4 power. Exponent of n is your numerator. This index is going to be your denominator. And then minus log of m to the 5th. Now for each term, I'm going to apply the power rule by putting the exponent in front of the logarithm. So here, log of p to the 9th, that 9 will go in front of log of p. Plus the 1/4 for log of n to the 1/4, that 1/4 will go in front of log of n. And then minus for log of m to the 5th, that 5 goes in front of log of m. So this will be my expression expanded as a sum and a difference of logarithms here. 9 times log of p plus 1/4 log of n minus 5 log of m. Alright, number 27. Solve the logarithmic equation of log to the base a of x plus 4 plus log to the base a of 6 equaling to log to the base a of 42. And you're to check your proposed solutions here. I'm just rewriting the equation. Now, notice on the left-hand side, I got the sum of logarithms. So I need to apply the product rule here. Okay? when you have the sum of your individual logarithms, we can condense that as a log of the product. So this will be log to the base a of, and I'm going to put the 6 in front of x plus 4. Then that's going to be equal to log to the base a of 42. Now notice got the log of the same base on both sides, so I can apply what they call the one-to-one property by setting this expression to be equal to that expression. Okay, that's the one-to-one property. If log to the base b of m equals log to the base b of n, then m equals n. So here I can set that 6 parentheses x plus 4 equal to 42. And then solve this equation for x here. So 6 times x, that's 6x, plus 6 times 4, that would be 24, equal to 42. And then get 6x by itself by subtracting 24 on both sides. So here 6x is equal to 18, divide by 6, x is equal to 3. Now that's my proposed solution for that logarithmic equation. But of course I have to do the check by replacing the x with 3, I'm sorry. Because x is equal to 3. So I have log to the base a of x is 3 plus 4 plus log to the base a of 6 equals log to the base a of 42. Now 3 plus 4 is 7, so log to the base a of 7 plus log to the base a of 6 is equal to log to the base a of 42. Now notice on the left side I have the sum of the individual logarithms. I'll condense that as a log of the product. So the left side will be log to the base a of 7 times 6 is equal to log to the base a of 42. And if I multiply 7 times 6, I will get 42. So log to the base a of 42 is the same as log to the base a of 42. So that checks. So here x equals 3 is the solution to that logarithmic equation. Number 28. Solve the logarithmic equation of log to the base 6 of x plus 5 minus log to the base 6 of 7 equal to 2. And again, you're going to check your proposed solutions here. So this is log to the base 6 of x plus 5 minus log to the base 6 of 7 equals 2. The left side I need to condense as a single logarithm because I have a minus sign in between the two logarithms. That tells me I have the difference of their individual logarithms. I can condense that using the quotient rule by writing it as the log of the quotient. So this will be log to the base 6 of x plus 5 over 7 equal to 2. So I'm applying the quotient rule here. Now since I have the log on one side of the equation, I cannot apply the one-to-one property. I need to write this as a equation in its equivalent exponential form. So here, the subscript is 6. That's going to be the base. This 2 will be your exponent for 6. So that would be 6 to the second equaling to what's after the log, x plus 5 all over 7. That's your logarithmic equation written in its equivalent exponential form. Now, solve the equation for x. 6 squared will be 36, so that will be 36 equal to x plus 5 over 7. Now I need to get rid of the 7 that's in the denominator, so I need to multiply both sides of this equation by 7. Now, if I multiply 7 times 36, that will give me 252. That's equal to, these 7s divide out on the right side. I'm left with x plus 5. So I have x plus 5 is equal to 252. Subtract 5 on both sides. That will give you x is equal to 247. So that's my proposed solution. Now for the check. Take the original equation and replace the x with 247. So I have log to the base 6 of 247 plus 5 minus log to the base 6 of 7 equal to 2. Now 247 plus 5 will give you 252, so log to the base 6 of 252 minus log to the base 6 of 7 equals to 2. Now again, the difference of the individual logarithms is going to be the log of the quotient. So it'll be the log of 252 divided by 7. That would be equal to 2. Well, 252 divided by 7 will be 36, so log to the base 6 of 36 should give me 2. Convert that into its equivalent exponential form. You're going to have 6 to the second equaling the 36. And if you simplify 6 squared, or 6 times 6, that does give you 36. So I can conclude that x equal 247 is the solution to that logarithmic equation. Alright, number 29. Solve the equation, or exponential equation, 10 to the x minus 7 is equal to 18. Round to the nearest hundred. What are 2 decimal places here? In this case here, we got a base of 10. So instead of taking the natural log on both sides, it would be much easier to take the common logarithm on both sides of this equation. So I'm going to take the log on the left side and on the right side. Because on the left side, if you have the log of 10 to whatever your exponent is, it's going to be that exponent. Because log to the base 10 and base 10 itself are inverses here. So log to the base 10 of 10 to the x minus 7 would just simply be x minus 7. And that's equal to the log of 18. And then we can solve for x. So here we're going to add 7 to both sides. So I have x is equal to, I'm going to put the 7 plus log of 18. And then we want to round to the nearest hundred. So here in the calculator, I'm going to type in 7 plus, and then press the log key, and then 18, close parentheses, and then hit enter. Now the 2 decimal places, I'm going to have 8.26. So x will be approximately 8.26. Now, you could do this, log of 18, if you wanted to, but make sure you close the parentheses because you only want the log of 18, and then plus 7. Okay? Because if you press log and then 18 plus 7 and not put a parentheses around the 18, you're going to get a wrong answer. Alright, and finally number 30. How long will it take for $5,000 to grow to $7,500 if the principal was invested at 7% annual rate interest compounded continuously? Round to the nearest tenth. Your answer to the nearest tenth. Okay, so we have a principal of $5,000. We wanted to reach the $7,500, so that's what A is equal to. The interest rate is 7%. Now 7% as a decimal, if you recall, is 0.07. And it's compounded continuously, so we need to use this formula. A is equal to P times e to the RT. And then we substitute the A, the P, and the R in that equation because we're finding out what T is. So your A is 7,500 equal to P, which is 5,000, times e to the R, that's going to be 0.07, times T. And then the next step would be to get e to the 0.07t by itself. It's being multiplied by 5,000, so we need to divide both sides by 5,000. So that means I'm going to have e to the 0.07t equaling to 7,500 divided by 5,000 would be 1.5. So I have 1.5 equaling to e to the 0.07t. And now, since e and the natural logarithm are inverses of each other, this is an exponential equation, so I need to take the ln on both sides. Because I know e and ln are inverses of each other. Because ln of e to the 0.07t, ln of e to whatever that exponent is that exponent. So I'm going to have e to the 0.07t equals ln of 1.5. And to find out what t is, or to solve for t, we divide by 0.07 on both sides. So now you're going to have t is equal to, press the ln key, 1.5, close parentheses, divided by 0.07. Now we're rounding to the nearest tenth or to one decimal place, so this will be approximately 5.8. And that time represents 5.8 years. For a $5,000 investment to reach $7,500 at 7% compounded continuously. Okay. So that's basically what you'll see on your final exam. If you have any questions, do feel free to email me if you need additional help. And best of luck to you on the final exam.